All right, let's get into our second challenge within this section on classes. This is going to get you some more hands-on experience, and it's also going to challenge you with everything you've learned up to this point. See if you can put it all together. Okay, let's just dive into it. So what I would like for you to build is a program where you can add crafting materials, like how Minecraft has different kinds of materials, to a database. This should seem pretty similar to the challenge from last time. I want you to create them in 3 different ways, using a blank constructor, a constructor with parameters, and using a custom method within your database script, right? So all of this you learned in the last video, if you did that. If not, go check it out real quick. Then I'd like you to be able to transition your script to be able to add materials through the inspector in the editor by serializing your custom class. And lastly, this part is new. Go ahead and transition your script to be an array of crafting materials that you can assign in the inspector. This is a big challenge. It's got about 4 big parts to it. So go ahead and pause the video here and try to complete this challenge on your own. And no worries if you get stuck or if you just want to see the solution to it, I will show you a solution right now. So in the last couple challenges, I've created both of our custom class and our mono behavior class in one script. This time I'm going to do them separately. So let's go ahead and create a new mono behavior script, and I'm going to call this crafting material. Now I know I created this as mono behavior, but we're just going to remove everything because this is actually our custom class. I didn't actually give you any traits in the instructions. I'm just assuming that you will pick out some traits that you like. So I'm going to say public string name, maybe public int ID, public string description, and it totally could have more than this, but we'll just do 3 for now. Now let's go ahead and create our database script. So I'm going to right click and create a mono behavior script, and this will be our crafting materials database. Now this one I do actually want to attach to an object, so I'm going to put it on, oh, I still have stuff left over. Love that. Hold on, let me delete that. All right, I'm going to create an empty and call it material DB and attach the crafting materials database to that. Beautiful. All right, so in our crafting materials database, let's say we want to create wood, right? Wood is a crafting item. Maybe it's one of the first materials you collect in Minecraft. So let's make wood exist. So I'm going to say crafting material wood, right? And then in start, which I just deleted, there we go. In start, we can say wood equals a new crafting material. So this right here, we're about to initialize it using a blank constructor, right? So we will be using, well, there's no constructor yet. So let's make a blank one. We can say public crafting material, open up parentheses and brackets and just leave it blank. And now we'll be using that blank constructor with no parameters, right? So we will say wood.name equals wood, what else do we have? ID equals 1, wood.description equals from a tree. Great. All right, now imagine once again that we have hundreds of crafting materials, and typing them all out like this would be super tedious. Nobody wants to do that. So let's go back into our crafting materials custom class, and let's create the second part of our challenge, which is using a constructor with parameters so that we don't have to initialize everything ourselves. So let's create a public crafting material, and in this constructor, we'll be taking in a string name, an int ID, and a string description. Inside here, we can say this dot name equals name, this dot ID equals ID, and this dot description equals description. Sweet. Now that we have this back in our database script, we can define another type of material. We can keep wood the same since wood is using that blank constructor, but now for the next one, let's say we want to create a crafting material that is dirt. And in start, we can create dirt equals a new crafting material. And in our parentheses, we can start to type in dirt. We can type in, ooh, and take a look now. When we mouse over, it says that there are multiple overloads. An overload is, I wish it would show us, let's say what is the second part? Maybe it's number 2. And then there it is, finally. So an overload is this. This is showing you the constructors that we made. Crafting material blank, that's what wood is using, and crafting material material with 3 parameters in it: a name, an ID, and a description. So the description will say, it's so common. Cool. Okay, so now we have wood and we have dirt. And you can see how it's possible to create materials for your game. The third way that we need to do this is we need to create a custom method within our database to create materials for us, right? So what we could do is we could go down below start and we could create a void create a crafting material. And in this method, we will add in some parameters: string name, int ID, string description. And notice that this looks kind of a lot like our constructor in our custom class. Pretty much very similar. So inside the curly braces, we can say crafting material, let's call it material, equals a new crafting material, name, ID, description. And at this point, now that we have this custom method in start, let's make a new material. This one will be, let's say, wool. And we can simply say create material, create a crafting material, and we're going to call it wool, ID number 3, and from a sheep. Whoa, sweet. Yay! Awesome. The slight problem with this kind of method is we're creating a crafting material, but we don't actually have a handle to it, right? Like this here is called dirt, wood. We can say wood.name, but here we don't have a handle to this. So let's change this method real quick. I'm going to change this to a return type method. So instead of void, it's going to be a crafting material method. And it's upset it turned red because it doesn't have a return line in it. So I'm just going to say return material. Now up here, we can get a reference to it. We can say crafting material wool equals create a material. So we have many ways to create materials. We have 3 different ways: using a blank constructor, using a constructor with parameters, and using a custom method here. This is just another way for you to work with custom classes. Okay, so the next part of our challenge is to be able to transition our script to add materials through the inspector in the editor, right? If we took a look at our script right now, nothing is visible in the inspector, right? And if we look at our crafting materials database, we don't have public or private reference for our wood or our dirt. So let me go ahead and say public and public. And if I save the script and hop back into Unity, you'll notice nothing. We made them public, but we still can't see them in the inspector. Even if we add the, our good friend serialize field to the top of this, let's go ahead and see if that will be in the inspector. And it's not. Our script is compiled and we still can't see it. This is because, I hope you remember, in our crafting material script, in order for these variables to be visible in the inspector, we need to add an attribute to the whole class called system.serializable. And then let's go ahead and save and hop back into Unity. And when it compiles, yay, you now can see wood and you can see dirt. And remember, there's no info on here because we assigned these 2 crafting materials in the script. So when I hit play, now it populates with all that information from our script. Sweet. And we don't see wool because wool was created down here. So what I could do is I could just go up here and we could say public crafting material wool, and then down here, remove that declaration there. And now wool should be available as well. All right, wool exists. There's no information, but as soon as we hit play, all of our information is populated. Yay, awesome. Now, the very last part of our challenge is to transition our script to be an array of crafting materials that we assign in the inspector. So we type everything in. So we're going to do a thing in our database script. All these beautiful things that we just did, we're going to delete all of it. And we're going to delete it here. So we just have actually an empty script. I know, I'm sorry, I know. And at the very top, all we need is one line: public crafting material, add your array brackets, and let's call this materials. Go ahead and save. And when we look into Unity on our database object, we now have an array of materials. And if I type in, let's say 100, I now have 100 different elements. I can open it up, and what's inside is our name, our ID, and our description. And one kind of cool thing, so we could go through and we could create a wood, ID is 0, and description from a tree. And notice the name, because it's a string property, it automatically updates the name of the element. So it's no longer element 0, it just is called wood. It's kind of a cool thing within Unity. And lastly, this is a small, tiny thing that's not part of our challenge, but I'll show you anyway. If we go back to our crafting material database, and let's say we realize, oh my gosh, there's more information that we need our materials to have. have. It's not just a name, ID, and a description. It's also a private integer for the damage amount. It's also a public integer. It's also a public sprite, the image icon of what appears in the shop. It's also a public int for the cost. There's all these features that I forgot to add when we made this class. Well, you can add these variables, save. When you hop back into Unity and you go to your database, now Wood also has spaces for the damage, the image icon, the cost. All of these elements do. Yay! Okay, I hope you had fun this challenge. This has been a good hands-on experience for how to use custom classes, how to use system serializable, how to make different kinds of constructors, and how to utilize custom classes within the inspector so it makes sense for you, the designer. All right, we have one more challenge here before I'm going to introduce something called class inheritance, but good job in this one. Give yourself a round of applause, get yourself a treat, and I will see you in the next one.